Welcome to Algebra 1, Semester 1, Unit 3, Section 4.4. We are going to be graphing using slope and slope-intercept form. So, sorry, didn't mean to move that camera. Okay, let me just mess with it for a minute. Okay, what is slope of a linear function and how do we find it? Many of you will think of slope, and luckily, because you've been taught well, you will think, oh, that's rise over run. You're exactly right. I just want to get better at spotting where it's at and making sure that you always rise and run. How are discrete and continuous linear functions alike and how are they different? That's a review question. Okay, so make sure that you go back over that one. That's something you should have learned from the last lesson. So answer that and then come to class. We're going to discuss that one, so bring that answer. Can you find the slope of a line? And you're welcome to look that up online if you aren't quite sure. Feel free to do a search on it. Can you find the slope of a line using a graph? Okay, you know that slope is rise over run. So if you look at this line here and you find where it perfectly crosses hatch marks behind it, you might see a point right here at -1, -2, -1. That's one point where it crosses perfectly. Another point where it crosses perfectly would probably be right here at 0, 2. So in order to find our slope, we would ask ourselves, well, how far are we rising to get from one point to the other, and how far do we run? So we rise, if we darken this in, we rise 1, 2, 3, and we run 1, 2. Now it's real important to ask yourself, did we run to the right, which is positive, or to the left, which is negative? We ran to the right. So this is a positive 3/2 on our slope. Okay? Another thing to remember is anytime you look at a graph and the line is going up on the right-hand side, it's going up to the right-hand side of it. Anytime it comes up to the right, even if it's over here in the left part of the graph and it's going up like that, that's to the right side of the line it's going up. If it's coming up on the right-hand side, raise your right hand right now and say, I swear to tell the truth, the whole truth, and nothing but the truth, so help me God. That was put in our court system years and years and years ago. That was a positive move for truth and freedom through the truth. So that was positive. If it goes up to the right, it's positive. Now let's look at a line going to the left. Well, first thing we'll say is, it's going to the left. It must be negative. We'll see if that's correct. But the way to remember that is Beyonce really helped us out with her song, to the left, everything you own in the box to the left. That was a negative statement, so you click your left hand when you see it going up to the left and you think, she was kicking him out. That's negative. So if it goes up to the left, it's negative. Okay? Now let's go to our graph and find points where it crosses the hatch marks behind. I see one here, right on the axis. And then if you come over here, actually come over to +2 and up 1, that's the first time that we see it cross perfectly again. Okay. We want to find our rise over run. So we rise to get from this point up to this point. We rise up there, make a square corner that way. How many did we rise? We rose 1, 2, 3, and then we ran 2 to the left. So we write our rise over run, 3 over 2. But this time we ran to the left, so we have to make sure and say, that's a negative slope. Okay? Make sure to mark it as a negative slope. That was the bottom of page 5. Now on to the top of page 6. We need to classify these linear functions. Graph each function. Y equals x plus 2 with this domain. So we need to take this graph and plug in these x values. When x is equal to -1, we plug it into the equation. X plus 2 equals y. And we say -1 plus 2 will equal 1. So that is our first point, -1, 1. So we'd come down to the graph, go -1 on the x, and up to 1 on the y. Next number, 0. 0 plus 2 equals 2. So 0, 2. We come to the y-axis. There's our origin. We don't go left or right because it's 0. So we just come up to 2 on the y-axis. Next point, 1. 1 plus 2 equals 3. So our point is 1, 3. Come over to 1 and up to 3. You can pause the video if you'd like. I'm going to fill these in. Now, our domain does not indicate that we can look at the numbers in between these points, so we have to leave these as independent points. Please label whether that's a discrete or continuous graph. On the next graph, it says we need to consider the domain as greater than 0. So this time, we don't need to plug in independent points. Instead, we look at our equation. X plus 2 equals y, and we ask ourselves, okay, how do we graph from the equation, this being our y-intercept, because it is not connected with the x, it's not multiplied by the x. The number in front of the x that is being multiplied is considered the slope. We don't write it, it is a 1. In this case, it's a 1. It's not always. So this is your slope. And remember, slope is rise over run. This should all be review. If it's not, just keep rewatching the video. It will make sense as you study it out. That number was 1, so 1 is equal to 1 over 1. So we're going to rise 1 and run 1. From the y-intercept, which is 2. So we go to the y-axis, it intercepts at 2. We rise 1 and run 1 to the right because it's positive. And now we draw a continuous line. We make sure that the line doesn't go this way because it said the domain's just greater than or equal to 0. It just stops right there at 0. Okay? So you label which one is continuous and which is discrete. You need to classify those two before class. We'll be discussing that. Okay, in the following ones. Without using a graph, could you tell me whether this is continuous or discrete and whether this is continuous or discrete? We will answer those in class. So make sure that you ask if I forget to ask you. Okay, can we calculate the slope without having to draw it on the graph? We know that we can count it on the graph because we count it as rise over run from one point to another. Well, if we're counting rise on a graph, which axis is it that rises? If you said y, that's correct. So we do a delta y, which means change in y, over delta x, little Greek symbols, means a change in x, meaning the run. We probably want to go further than just putting the Greek symbols with those. Let's take the y over x from one point and simply subtract the y over x from another point. Then we should be able to get our slope. Now, in order to distinguish which is from which point, we just put a 2 with these and a 1 with these, and that signifies this is from one point, that's from another. So you go to your point, you label it x, y, x, y. Now, it does not matter which one you designate as being 2 and which one is 1. This one needs to go together, so it would be negative 5 over 3, or you could have put it in at the second spot, minus negative 1 over negative 3. Don't forget to bring the negatives in there, even though you have a negative already in there from the difference. You're seeing how much it changes. So negative 5 plus 1 over 3 plus 3. Negative 5 plus 1 would be a negative 4. 3 plus 3 is 6. So we end up with a negative 2/3 when we reduce it. That is our slope from one point to the other. Let's do that again. We label x, y, signify the difference in the 2 points, so 2 and 1. Now we write our formula, y squared minus y1 over x squared minus x1. Now we go ahead and we plug in our values. This is the x2 and y2, so we put negative 2 over 3 minus negative 2 over 5. Now a negative 2 and a plus 2 would equal 0. 3 minus 5 is negative 2. Anything with a 0 on the top of the fraction is equal to 0. So we have no slope on this. Now I would prefer, rather than you writing no slope, I would prefer that you realize it has a 0 slope. But I've heard a lot of you say no slope. 0 slope, and that it's a horizontal line. Doesn't go up or down, either one. Okay, that's the end of that section of our notes.